Hi, today we'll talk about Model Context Protocol. So, Model Context Protocol has taken the developer world by storm. It is an open source framework that was launched by Anthropic, the company behind the large language model Claude, and ever since its launch, almost 3 months back, we are seeing a huge adoption. And there is a particular reason for that. Now, fundamentally, the way that we interact with large language models is that you might go to a chat interface like ChatGPT or Claude and ask a question, and the large language model will generate a response. While it is great at doing that, today we are seeing a fundamental shift in how we are actually interacting with AI systems. Thanks to rise of agentic AI, where the basic idea is that these models can get access to external tools through which they can no longer now just be limited to text generation, but actually carry out tasks for you. And one of the fundamental concepts over here is what we call as tool calling. So as we know that fundamentally these large language models cannot really do much beyond text generation. So if you probably are trying to ask questions related to a real-time API, or you want the ChatGPT or the LLM to retrieve some data from your database, that would not be technically possible. But that's where tool calling comes into picture, where the LLMs can get access to external databases, APIs, tools that they can leverage. And based on the input query being given by the user, they will analyze that query and see whether they should just give a text-based response, or they can use one of these particular tools at their disposal in order to further augment their response and give real-time updates, or even access to proprietary data that might be stored in a database. So MCP protocol allows you to give enhanced experience of the LLMs like Claude to be able to use external tools and data to augment responses that they are providing to users based on a certain query. So this expands the number of potential use cases that you can think of. And in today's demo, I'll be showing you how we can build model context protocol servers. So these servers are meant and you can use TypeScript SDK or the Python SDK and define these servers with the set of tools that the Claude model, in that case, like in that, if you're building it with some other LLM, how these models can use these set of different tools that are now accessible to them and perform actions beyond just the text generation capability. So for this example, I am going to show you how I've built a model context protocol server for being able to find out Star Wars related planet data. So for example, let's say that if Claude didn't have information about the different Star Wars universe planets, now it will be able to retrieve data about these Star Wars planets with the help of a database like Couchbase, find related planets with the help of the Couchbase vector search, and also generate an image about how that planet might look like with the help of the Nebius AI Studio. We'll cover about the Nebius AI Studio and the model that I'm going to be using for generating the image a bit later. But first, let's look at how the experience of building an MCP server look like. So in this case, I am right now inside of my cursor, and the first thing is that you will be able to use either the Python SDK or the TypeScript SDK. In this case, I'm going to be using the Model Context Protocol Server SDK for TypeScript. So this will help me to define my Model Context Protocol server. Now what would happen is that as I will define the server and I will define the set of tools, these tools will automatically be identified by Claude. Like let's say if you're using the Claude desktop, it will automatically identify these set of tools. And based on the prompt that the user gives, it will intelligently understand whether it should use a tool or not. And if it does end up using that tool, then of course it will use the functionality. So we'll go step by step and see how this actually works. So here we are importing the two main things which are responsible for our setting up of the Model Context Protocol server. Now, we have a bunch of different inputs over here. One is Zod to JSON schema. So Zod is of course helping us define the types and the input schema that we have, because of course one thing to keep a note here is that these model context protocol, it requires you to have like a JSON input schema which will be used to understand based on the prompt that the user has given how the data, or in this case like Claude, if it's basically using the tool, it will need to use the JSON input, and then when it generates a response, it generates a response based on JSON, and then that is sent back to the Claude model to then augment the response. So we need to keep that in mind. So since this is TypeScript, we are using Zod for our type safety and defining the types, and then we use that Zod to JSON schema that will be then used because the model context protocol accepts JSON schema as input. And then we have a bunch of imports that we are primarily going to be using for our Claude to be able to interact with an external database like Couchbase. So initially we start by defining our Star Wars data. So in this case, as I mentioned, that our model context protocol server here is going to be retrieving data about Star Wars planets in the universe. So here we just define all of the types, including things like the name, rotation period, the embeddings that we are going to be generating. And now first also look at the schema. So here we have just defined the schema definition for Star Wars based on the types that we had defined, right? So we define the Zod schema definitions for all of the types. Then we have just some of the additional functions like the environment variables for our database and just some functions to initialize our database over here. Now, first, let's look at whenever you're defining your model context protocol server, so the MCP server, you define the set of tools. So the set of tools are available to us by defining the server.setRequestHandler, which defines the set of different tools. So in this case, the tools that we have defined is fetch planet name. So for example, if you give a prompt, tell me about the planet Nabu. So it will, what would happen is that when you give this input prompt and the set of tools have been registered by the model context protocol and you're using it with Claude, it will identify, okay, what is the particular tool that is most relevant based on the particular input prompt that the user has given. So in this case, what actually helps Claude to identify what tool to use. So the description of the tool and the name, that is what actually helps. And then you define the input schema over here that will be used by the Claude over here for the MCP server. So based on the type of interaction that you want to have. So if you are just probably asking a question related to, hey, what would be, fetch me the details about this particular planet. And in that case, it will be able to use the tool fetch planet name. In case you are trying to generate an image for a particular planet, then you can just ask it, hey, generate an image for me for the planet Nabu or Aldran. And in that case, it will pick and choose this particular tool. So it will automatically identify what tool to choose. So here, with the help of the server.setRequestHandler, we are able to define the list of available tools. And when it actually comes to the fact of tool calling, that means that now when you have given the input prompt, the Claude has identified that it has to use this particular tool. Then this is where we have defined the set of request handlers, and we have built like a switch case where based on the prompt, it will identify that it has to use that particular tool, and then it does the function calling and uses the appropriate request handler for that specific tool name that we have defined over here. So for example, for fetch planet name, it uses the input prompt and it identifies where we have actually set the input and we have given the name of the planet, and then it fetches that from our request body, and then it uses the get character function to actually fetch the details about that particular planet. Then, for example, if you are trying to find similar type of planets, so of course, it will first fetch all of the information that it got about the existing planet, and then it will call this function called find similar planets or find similar characters to identify the similar type of planets that it will use. And finally, for example, like if it wants to generate a planet image, so of course it will again find the planet from our database that it has found based on the input user query, and it will then use this function generate planet image to actually generate that image. So the idea is that these function definition or tool called definitions that we are seeing with the help of these request handlers, they are calling actually defined functions that we have defined for being able to fetch data from our database, generate image with the help of Nebius AI, and these are executed by the model context protocol, and then the results that come from these outputs that we generate are then used to render the response by the LLM. In that case, it would be Claude. So you can see that we have defined some of our core functions over here. For example, in order to get the database collection, then we have the get character. So this one basically just goes ahead and uses the collection where we have defined all of our Star Wars planets, and it will find the planet based on the name that we fetch from the input query. And then once it has found, it will retrieve all of the data based on that particular collection. And now, of course, when it comes to finding similar type of characters, this is where we are going to be using the vector search. So the first thing that it will do is that it will retrieve the embedding for the planet that we have retrieved based on the input query. Then what it will do is that it will define the vector search index that we have within Couchbase, and then we set up a new vector search query where what it will do is that based on the input embeddings that we have for our planet for which we need to find the similar characters, it will go ahead and actually execute using the scope.search where we define our vector embedding index, right? So we will find the related set of vectors or embeddings that most closely match for our input embedding, and we will return those set of embeddings and the corresponding planets that are the most similar. So by finding the most relevant or the closest set of embeddings, that means that those are the planets that have the closest set of features for our given input planet, and we will showcase those results. So that is what we basically do. We return the details about all of those particular planets, including the score, to find the set of nearest planets, and then we just go ahead and show these results with the help of the model context protocol. Now, of course, with respect to the generate planet image, so if you want to generate like an image for the planet that we are trying to find, here we are going to be using Nebius. So if you're already not aware of what Nebius AI Studio does, it provides a set of different types of open source large language models, and including that can do different things. Like for example, if you want to just do text to text, you can use the different type of models like Llama 3, and including like some of the latest state of the art models like DeepSeek R1, DeepSeek V3. If you want to generate embeddings, you can use these models. The model that I'm specifically going to be using is the text to image model, which will help me to generate like an image based on a particular text. So in this case, I'm using the Flux model. So in order to initialize that, you use the OpenAI client, and you provide the base URL as Nebius Studio, and you provide your API key, which you can generate very easily in the API keys section. and then we use the clients.images.generate. Over here, we also provide a prompt. So here we say that we'll be creating a realistic astronomical image of a Star Wars planet with the given name, and then we give the response. So we pass the model. In this case, we are going to be using the Flux Schnell model. We provide the input prompt. We want the response to be in base 64 JSON because that is the type of response accepted by Claude MCP, so the model context protocol. So we go ahead and we just define that, and then we initialize our Star Wars server. So this is basically where we initialize our model context protocol server. So it has the name Star Wars server. And then once you go ahead and do this, one of the other steps to also ensure that you have when you are defining the model context protocol is that you have to create a model context protocol JSON file. So in that case, you define all of the JSON data about what all environment variables your model context protocol will actually end up using. So you define that, and then when you open up Claude, in this case, you can see that if I have opened up Claude over here. First, let's try to identify, just to kind of show you an example of how this will work. So I'll say, show me planets that are probably similar to the planet Alderaan and include an image of Alderaan. So first, let's run this and see how the model context protocol basically works over here. And then we'll also just dive deeper into how the listed set of tools look like when you're using it with Claude. So in this case, I'm going to be asking it to find me planets that are similar to Alderaan. So when the model context protocol will be running, it will automatically be able to identify what particular tool the Claude needs to use from the model context protocol, because we have these set of 4 different tools, and what particular tool it should actually use. And then it will start to execute and use that tool to generate the response, and then your LLM response will be enriched by that tool call that we have done. So see that as soon as I call this, it will start to use a tool. In this case, it's using the tool find similar planets to find a planet that has the data for Alderaan, which is able to correctly do that. Now what it's doing is that it is generating an image of the planet Alderaan, which is able to do it by using this particular command, which is the tool for generating planet image. So if you look at, first of all, the first tool that it called was to use the find similar planets, where it used the data of fetching the name from the prompt, and then it used that to fetch the relevant data over here. In this case, it first of all fetches the Alderaan data from our Couchbase database, and then what it does is that it uses the vector search to find the topmost similar type of planets that are closest in terms of their appearance to Alderaan. And it also gives you a score of match. So this is the vector store score that you get to find what are the closest related planets. Then what it does is that it uses the generate planet image tool that we have defined. If you see, this is the image that has been generated with the help of the Nebius AI Studio, and here we're using the Flux model. So based on the description of the Alderaan planet, it uses that description in order to generate a realistic looking image, and then it uses the information that it got from the tool call for finding the similar planets, and with the help of that JSON, it shares what are the planets which are similar to Alderaan, and it shares with you the climate, the terrain, all those details that it fetches from that structured JSON output that we receive from the tool call. Then it uses that JSON object details and renders that on the display over here when we are using the Claude. So you can see that in this case, if Claude did not have access to details about the Star Wars planets, it was able to access not only the database, external database, which is the Couchbase here, but also then leverage external APIs. In this case, we're using the Nebius AI Studio API, and we are generating image based on that. So this empowers the models like Claude to be able to make external tool call and access external databases, make API calls. So you can now expand this use case to anything. For example, you could use Claude to find out the latest weather right now in a particular location, and then give it access to an external API to order clothes for you based on the current weather conditions and deliver it to your home by providing it access to your credit card information. And the opportunities are limitless because now you can just give access to any sort of API. So whatever kind of use case that you can think, you can basically do that in this scenario. So this is like an example, and just to kind of show you how this looks on the Claude side. So here you'll be able to see that these are the 4 set of MCP tools that are accessible. So these are what we had defined in our MCP server code base, these list of 4 different MCP tools. So based on the prompt that you give to your Claude, it will automatically be able to identify whether it should use an MCP tool, and based on the description of the tool, it will be able to then automatically use the appropriate tool. In our case, when we asked it, tell us details about the planets which are similar to Alderaan and generate an image, it knew that it needs to basically use the fetch planet name and then the planets which are similar. So it used these 2, and then it did the generate planet image to generate the image using the Nebius AI. So this is a quick overview of how you can leverage the model context protocol to further enhance the capabilities of large language models with the help of tool calling. And now you can very easily build agentic workflows where your LLMs not only are able to generate text, but they are able to access external databases, tools in order to further augment your responses and the capabilities that are offered by these large language models.